Hello everyone, we are going to discuss question number 37 from MTP3. Here a beam of X-ray which is having a wavelength of 0.2 nanometer is made to fall on a free electron. Then it will get scattered and then we have to find out the maximum wavelength shift as well as the percentage energy loss of the radiation. So we will start with the wavelength shift. Wavelength shift is given as delta lambda equals to h upon m naught c into 1 minus cos theta. So the wavelength shift will have a maximum value when 1 minus cos theta will be maximum, and this will be done at theta equal to 180 degree. Substituting all the values and constants, we will get the maximum wavelength shift as 4.852 picometer. Now we have to find out the percentage of energy loss. Percentage of energy loss is given as change in energy divided by the total energy, initial energy, multiplied by 100. We know that change in energy will be in proportion with maximum wavelength change divided by initial wavelength multiplied by 100. So we will substitute the value of change in wavelength as 4.852 into 10 raised to power minus 12 meter divided by the initial wavelength, that is 0.2 nanometer, so it will be written as 0.2 into 10 raised to power minus 9 meter multiplied by 100. So the percentage energy loss will be 2.426%. Hello everyone, we are going to discuss question number 40 from MTP3. We have to find out the effect of increase in pressure on the following reactions and also mention what will be the resultant direction of the reaction after the increase in pressure. So we will start with option A. Here we will apply Lee-Catlier's principle. So according to this principle, if we increase the pressure, then the reaction will proceed in such a direction to decrease the ultimate pressure of the reaction. So in option A, we are having 3 gaseous reactant and 3 gaseous product. That means number of gaseous reactant and number of gaseous products are equal, so there will be no effect of increase in pressure. Now coming to option B, we are having 1 gaseous reactant and 2 gaseous products. Here number of gaseous products are more, so there will be a effect of increase in pressure. The reaction will try to decrease the pressure, so the reaction will go in backward direction, as in the backward direction in the reactant side number of gaseous species is less. Now coming to option C, we are having the number of gaseous reactants as 9 and the number of gaseous product as 10. So if we increase the pressure, then the reaction will try to minimize the pressure by proceeding in such a way such that the number of gaseous species decreases. So number of gaseous species will decrease if the reaction will proceed in backward direction or in left direction. So the reaction will go in left. Now coming to option D. Here number of gaseous reactants are 2 and number of gaseous products is 1. So in order to decrease the pressure, the reaction will shift in right hand side. So the correct answers will be B, C and D. Hello everyone, we are going to discuss question number 41 from MTP 3rd. Here using Bohr's model, we have to give the ionization potential of Li2 plus ion, that is similar to hydrogen atom. So we know that ionization potential for hydrogen is 13.6 electron volt, and we also know that ionization potential for any element is directly proportional to Z square, that means square of its atomic number. So the ionization potential of lithium will be equal to Z square multiplied by ionization potential of hydrogen. So Substituting the values, that is 3 square multiplied by 13.6 electron volt, we will get the ionization potential of Li2 plus as 122.4 electron volt. Hello everyone, we are going to discuss question number 43 from MTP3. In this problem, a radioactive source is given that have two isotopes. Both of them have an initial activity SAM, and that is 1000 ln 2 becquerel. Half-lives of the both isotopes is given, and we have to find out the number of nuclei that decays in the period of 4 hours. Using the provided half-lives, we can calculate the decay constants of both the isotopes. So decay constant for the first will be equal to ln2 divided by t half, that will be equal to ln2 divided by 3600 seconds, and decay constant for the second will be equal to ln2 divided by half-life of second isotope, that is 7200 seconds. Now we are given with initial activity, that is A1, and we know that activity is given by lambda into n, that is number of nuclei. So initial activity will be equal to lambda into initial number of nuclei, that will come out to be 1000 ln of 2. So the initial number of nuclei will be 1000 ln 2 divided by lambda 1, decay constant of first. Substituting the value of decay constant in this equation, we will get initial nuclei of first isotope as 3.6 into 10 raised power 6. Similarly, we will use the same concept to calculate the number of initial nuclei for second isotope. We will use the initial activity and substitute the value of lambda 2, and then we will get the n to know, that is initial nuclei of second isotope, that will be 7.2 into 10 raised power 6. Now we can calculate the number of nuclei remaining after 4 hours. For the first isotope, the number of nuclei remaining will be given as n1 naught divided by 2 raised power 4, that will be 22.5 into 10 raised power 4. Now number of nuclei remaining in the second isotope will be equal to initial nuclei divided by 2 raised power 4, 2 raised power 2, that will come out to be 7.2 into 10 raised power 6 divided by 4, and the remaining nuclei will be equal to 180 into 10 raised power 4. So the total number of nuclei after 4 hours will be equal to number of nuclei of first isotope plus number of nuclei of second isotope. Adding these both, we will get the number of nuclei remaining after 4 hours is 202.5 into 10 raised power 4. That means the number of nuclei that has decayed in 4 hours will be equal to initial number of nuclei minus the number of nuclei that are remaining. So that will come out to be 1080 into 10 raised power 4 minus 202.5 into 10 raised power 4. That means the number of nuclei that has decayed is 877.5 into 10 raised power 4.